Now let's see some basic concept of OSPF protocol, and this one can help us understand the working principle better. The first one is a router ID. And this router ID is a number that can uniquely identify a router who runs the OSPF protocol in the AS. That means you can think this is a name of a router if the router runs the OSPF protocol. And AS means the system used by a set of routers using the same routing protocol. Maybe when you do the configuration of OSPF, we don't have any command about the AS. But maybe if you deploy the BGP, the first step you have to create the AS number. So if the network management by the same organization, maybe by the company, maybe by the office, something like this, they will use the same policy of the routing. And within the organization, we will use the OSPF, and we can think they belong to the same AS. And each router that runs the OSPF must have a route ID, and the route ID cannot be duplex within the same AS. That's why we say this is a name. Also, you can say this is the ID of the router. And about this router ID, we can be configured manually by the command and also can be automatically selected by the system. Later, we will have some example to explain the router ID. And the next one is a neighbor. The first step, if we're running the OSPF protocol, we will send out the hello packets. And according to this packet, we can find some neighbor. And when we receive the hello message, we will do the parameters negotiation. And like the area ID, like the if you add the authentication function, we will test the password and also some hello packets. What's the time to send the message out? Something like this. If all the parameters meets the requirement, we can negotiate successfully. Then we will establish a neighbor. And we also will have a special status to indicate that we have the neighbor relationship. The status is two-way. And the next step, why we need to find the neighbor? Because we want to exchange some links data information. And not every neighbor relationship can exchange this information. Only establish the adjacency. The neighbor are not necessarily adjacent. An OSPF router can be called adjacency only if the link status information is exchanged between two routing devices and calculated based on the update database. That means if only when we have the relationship to establish the adjacency, then we will exchange the link data information. And after we get all the information, finally, we also will have a status to show us the status is is full. So if now there are two routers, I'm running OSPF and my router ID is 1.1.1, and this information will be added into the hello packets and sent out. And also if the other router runs the OSPF protocol and the router ID is 2.2.2, and this information will be sent to the link. And all the router within the same link will receive this broadcast message and check the parameters information. So they are basic three concepts of the OSPF. And the first one we call is the router ID. The router ID is very important. When you use the OSPF protocol, we need a name, right? And this one can be manually configured and also can select from the system automatically. And here as a principle, we suggest that you can directly use a command to show the router what's your router ID. not selected by the system, because maybe in the future your router start again, maybe we have to select a new router ID if we don't manually configure it. But if we don't manually define the router ID, how to select the router ID? And about the router ID format is same with IP address. So we will select some suitable IP address to become the router ID. And the principle is, if there is an active loopback interface locally, take the maximal value of the loopback interface IP as the OSPF router ID. Because about the loopback interface, this is a logical interface. And if the device is working, the status will be up. So if we have the loopback interface, we prefer to choose a loopback interface. If there is no loopback interface, take the maximal value of the IP address among the active physical interface. So the second principle is, if you have multiple physical interface, we will take the active one, that's when your status is up. Then we will select the maximal IP address to become router ID. So this is a principle. And during the project implement, a loopback interface is usually created and configured with an IP address, right? And then the OSPF router ID is manually assigned as the interface address. So we suggest to do this one. For example, you create a loopback interface and then directly manually define this IP address as our router ID. And here is an example. If now we have a router and we have three interfaces, loopback 0, gigabit 00, and gigabit 01, and three interfaces have IP address. In this scenario, according to principles to select the router ID, finally we will select the loopback interface to become the router ID 172.16.1.1. But about the route 2, if we have three interfaces, physical interfaces, 192.168.1.1, 2.1, and 3.1. If the physical interface gigabit 1/0 is broken, then we only will select the active physical interface and to become a router ID, the max value. So finally, the route ID will become 192.168.2.1. So this is the principle. And if you select the router ID by the system, maybe next time you create an interface and has higher IP address value. But pay attention. If the router is working all the time, the router ID will not change. But if you, for example, to reset your OSPF process or maybe restart your router, we will select a new router according to the a new IP address to become the router ID according to the principle. So that's why we suggest to manually define the router ID on the devices. So this is the router ID. And the second one is the definition of the DR and the BDR. You can think this is a master router or the slave router. But the first one, why we need the DR and BDR? This is a mechanism to reduce the number of adjacency relationships in the broadcast domain, reduce the flooding of LSA. This LSA is the detailed message in the packets like the LSU packets in the broadcast network and saving bandwidth. For example, in this topology, if within the same broadcast domain, there are 6 routers, right? 6 routers. If we don't have the DR and the BDR, the result is we have to take 15 pairs of adjacencies relationship. One router at least 5 relationships, totally 15 pairs. And all the information I have to send at least 5 messages. For example, like the DVD message, right? Because I have 5 neighbors and I have to send out 5 messages of the DVD. But as we know, they belong to the same broadcast domain. So if we only receive 1 DVD, that's enough. And in order to reduce the relationship, we will select the DR and BDR. And we only have to establish the relationship with DR and BDR and DR other. That's enough. So about the DR, we still have to establish the relationship with all the routers, the same with BDR. But about the normal router, like the DR other, we only have to establish 2 relationships is enough. We don't need to establish the relationship with the other DR other router. So that's why we want to select the DR and BDR. And pay attention, DR and BDR selection based on the interface. That means like this topology, the DR router have 1 physical interface to connect with 5 routers, and this interface maybe will become DR. But if we still have the other interface to connect with the other network also running the OSPF, maybe the interface state will become BDR or DR other. So pay attention about this one. Not means this router to become DR, only means the interface of the router in the broadcast domain 1, we will select a DR and BDR. And of course, in your real network, maybe we don't have so many routers interface will connect with the same broadcast domain. We only have 2 routers. Maybe one is DR and another is BDR. So in this scenario, we only have 1 relationship of neighbor and also will be the adjacency relationship. So this is the DR and BDR. That's why we have the other network type we call it point-to-point network. In this scenario, we can make sure that on the link we only have one link and 2 routers. So in this scenario, you can directly to change the network type to become point-to-point. This is no need to select DR and BDR because finally we must establish the adjacency and the neighbor relationship. But if you have multiple routers in the same network like this topology, you have to select DR and BDR. And how to select who will be DR and who will be BDR? We will compare the priority at first. The highest priority will become the DR. The second one will become the BDR. And the rest will become DR other. And about the priorities, the default value is 1. And if you don't change the value, that means all the router interfaces, the priority are same. And then we will compare the IP address. And the highest router ID will become the DR. If you use a command to change the priority to become 0, that means this router will not like to become DR and also cannot become the BDR. This is the normal router, only the DR other. So if we have the same priority, for example, we don't use a command to change the priority. The one with the highest router ID will become the DR. The second highest will become the BDR. So this is a principle. Because about the router ID, we say this must be unique in our network. And another principle is once the DR and BDR are selected, the DR and BDR will not be re-elective. Even if a higher priority routing devices is added to the area. Only participate in the election when both of DR and BDR have failed. So this is the principle. And the priority is based on the interface. And for example, someone say, I think the route 1 has higher priority. has higher performance, I hope that route 1 can be the DR router. So you also can use a command to change the priority, finally to let route 1 to become DR. And here is a basic one. If we use the command to change different priority for the routers, finally the right router will become DR other, and the left route 1 will become DR, the route 2 will become BDR. And the command is enter the interface. Maybe if you use a layer 3 switch, you have to enter the SVI interface and use the command IP OSPF priority to become 10 or to become the other value. If you use the router, maybe you can directly enter the physical interface to use the command to change the priority. So this is the basic one to select the DR and the BDR. And here is an example. If route 1, route 2, route 3, and route 4, all of them connect with the same segment, and we already give the route ID 1.1, 2.1, 3.1, and 4.1. According to the principle, by the default, or the priority, if we don't change, all of them, the value will become 1, right? So we will compare the route ID. The biggest route ID will become DR. So finally, the route 4 will become the DR. The route 3 will become the BDR. And the rest of 2 routers will become the DR other. And later, if we have higher priority router join the network, but we already select who is DR, who is BDR, something like this. And this one only can be DR other. So finally, if we add a router, route 5, and the router ID is 192.168.5.1, but the last rule is DR other. So this is route 5. And one route 5 will change the rule. If the DR is 40, maybe the DR cannot work, right? And then the BDR will become the new DR immediately because BDR already have all the information like the DR. And I'm only waiting when the DR is broken, I can immediately to take the work. So in these scenarios, route 1, route 2, and route 5, have to select a new rule to become BDR. So according to the principle, finally route 3 will become DR, route 5 will become BDR. And route 1 and route 2 will become a DR other. If route 3 is broken again, then the route 5 will become a DR. So this principle is used to keep the network stable. Okay, so this is a basic about the DR and the BDR selection. That's all about the concept when we send out the hello packet and to establish the neighbor relationship. And in this process, we will have some concepts like the route ID, like DR and BDR, and also we talk something principle, how to establish the DR and BDR, how to select the route ID. And pay attention about the router ID. If you don't manually config, we also can select from the system automatically, but we suggest to manually define the router ID. And the second one about the DR and BDR, they also will select automatically who will become DR, who will become BDR. But if you have different influence, for example, I hope that which devices can be DR, you can manually change the priority. Then the rule will be different. But if you don't change any command of the DR and BDR, and also you don't change any command to define the router ID, the OSPF still can work. So this is a basic when we establish the neighbor relationship by using the hello packets. And the next one, we will talk something how to exchange the RESTful type message to make the synchronization of your LSDB, your database, and finally to calculate the routing information.